Okay, we're looking at the Nelson College Maths and Stats exam, practice exam for investigate relationships between tables, equations and graphs. We're going to look at question number 3. In question 3, Alan, Brian and Colin are best mates. They've just finished school and all have good jobs. They're going to work for 12 months and then go travelling together around the world. The trip is going to cost them $4,096 each. And they each have a different plan for reaching their savings target of $4,096. Alan already has $1,000 in the bank and he's going to bank another $200 per month until he has enough money. Brian has no money saved yet, but his plan is to bank $2 at the end of the first month, have a total of $4 in the bank at the end of the second month, and a total of $8 at the end of the third month, and so on until he has enough money. Colin has formed an equation to describe the total amount of money that he will be in his bank at the end of each month. The amount y is 25 times x squared, where x is the number of months. Now we want to use tables, graphs or equations to investigate the 3 different savings plan and find out who reaches the $4,096 saving target first. So for Alan, he's got $1,000 in the bank initially, and he's going to bank another $200 per month until he has enough money. So I could describe Alan's savings in an equation. The amount he saves is y is 1,000, the initial amount, plus 200x, where x is the number of months. For Brian, he starts off, he's going to have at time 0 he's got 0. At the end of 1 month he's got $2. At the end of 2 months he's got $4. At the end of 3 months he's got $8. At the end of 4 months he must, and so on, he'll have $16. So this is doubling each time. So the equation for Brian is y equals 2 to the power of x. When x is 1, he has 2 to the power of 1, he has $2. When x is 2, he has 2 to the power of 2, which is $4. When x is 3, he has 2 to the power of 3, which is $8, and so on. So this is the equation for Brian's savings plan. It's an exponential equation. And Colin, we're told his is y equals 25x squared. So I've got 3 equations, and I want to see who reaches the savings target first. So drawing a graph of these 3 equations with the x values from 0 when they start through to 12 months, which is when they want to finish, should be able to tell me where. Okay, so let's give this a go. Let's go for 4,500 and 1, 2, 3, 4, 5, 6, 7, 8, 9. That'll be 9 lots of 500 down to the, oops, sorry, I'm off the bottom of the screen. So I've just chosen my scale of 500 increments. So this is the amount they've got saved. 3,000, 2,500, 2,000, 1,500, 1,500 and 0. And on this axis here I'm going to have the amount of time that they've saved for, so on my x-axis, and I'm going to have the start as 0, and let's have 1 month, 2 months, 3 months, 4 months, 5, 6, 7, 8, 9, 10, 11, all nearly ran out of space again, and 12. X and y, that's savings, and here's time in months. So Alan, y equals 1,000 plus 200x. So my y-intercept will be 1,000, and my gradient is 200. It says 200x. So I know that after 10 months there'll be an extra 2,000 in there, so he'll only be at 3,000 after there. Okay, I used 10 months to give me an extra 2,200 per month, just to make it easy to draw my line in. So it looks like Alan's going to come up short, because at 12 months he's only here. That's Alan. Who else have we got? We've got Brian, y equals 2 to the x. So I'm allowed to use my calculator in this standard. Let's see, if x were 10, 2 to the power of 10, so at 10 months he's got 1024, 10, 1024, at 12 months, oh, he's got the 4096, that's lucky. Okay, so at 12 months Brian's got the 4096, which is about here somewhere, and 250, 100, about there, so Brian's there. And we said at 10 months it's 1024, so he really accelerates his saving, and that's what happens with an exponential graph. Okay, at 4 months he's only got $16, so he's way down here. Let's chuck in a few more. Let's say at 6 months, what's he got? He'll have 2 to the power 6, which is $64. Okay, 64, still way down here, isn't it? And let's try 8 months. 2 to the power 8, 256. So he's getting up around here. When it's 8 months, it's 256. Now, if I had a bit more time, I'd work out all the values of x and for Brian, and then I'd be able to draw his graph. But you can see it's got this exponential shape. It's really starting to take off there. But he does end up at the 4096, and that's really encouraging, because we do want someone to get there in the 12 months. You know, he's got essentially nothing to start with, and then he races away at the end. So that's Brian. And now we've got Colin, y equals 25x squared. So that x squared is some sort of parabola, and the 25 means it's even steeper. But for Colin, I'm going to make myself a little table to plot his points. So x, let's go for 0, 2, 4, 6, 8, 10 and 12, and 25x squared. We'll just fill those in, use the calculator. Well, 25 times 0 squared, I know that's 0. 25 times 2 squared will be 25 times 4, so that's 100. 25 times 4 squared is 25 times 16, which is 400. 25 times 6 squared is 25 times 36, that's going to be 900. 25 times 8 squared is 25 times 64, I'm going to go for the calculator with this one, 1600. 25 times 10 squared, well that's 25 times 100, so that's 2500. And 25 times 12 squared, that's 25 times 12 squared is 3600. So Colin doesn't make it either. Colin gets to 3600, about here somewhere. There's Colin, and let's put in his other figures. He starts at 0, 0. At 2 he's got 100, so about here somewhere. At 4 he's got 400, so about here. At 6 he's got 900. 1900 is going to be about here somewhere. At 8 he's got 1600. 1500's there, and 8's there, so about there, 1600. At 10 he's got 2500, so at 10 he's got 2500, and he ends up at 12 up there. So this is that parabolic shape. It doesn't look very steep because of the scale I've chosen. Okay, so we actually ended up writing equations for everybody. We were given Collins. I used a couple of tables to draw Brian's curve and Colin's curve, I noticed that Brian's equation had to be that 2 to the power x because it's doubling each time. Now what did it ask us? Use tables, graphs and or equations to investigate the 3 different savings plans and find out who reaches the savings target first. Who? Okay, I'm just going to write in here, Brian is the first to reach the $4,096 savings target. He does this at the end of the 12 months. No one else manages to save $4,096 in the 12 months. Okay, let's look at the second part. Investigate. So again, we're going to investigate how to change the 2 slower savings plans so that all 3 friends reach their $4,096 target at the end of the same month. Okay, so Alan's, he was too slow, wasn't he? His savings plan was y equals 1,000, which he currently has, plus 200x is too slow. We want 4,096 to be the amount he has, the amount he's got to start with, plus this new savings amount. We'll call that K. If he saves K per month for the 12 months, he'll make it. So let's see. If I take 1,000 off both sides, 3,096 equals K times 12. Divide both sides by 12. The amount he has to save per month is 3,096 divided by 12. Let's see how much that is. 3,096 divided by 12, $258 per month. Okay, so Alan's revised savings plan would be $258 saved per month. Now it's not possible to go and say he just makes up the shortfall by depositing more in his bank at the start. That is how much he had. We need to look at how much extra he would need. Okay, who was the other one that was short? It was Colin. Colin, his savings were 25x squared, where x equals the month number. So what could he do? We want to now solve. He needs 4,096 at the end, so that's when x is 12, and let's say he has this j. Instead of 25x squared, he's got j times x squared, and we want, when at the end, when it's 12 months, 12 squared times j to be that 4,096. So 4,096 equals j times 144. So j is 4,096 over 144. J is what? 4,096 divided by 144. 28.444. 28.4. I'm going to round it to 28.45 to make sure he does get there. So instead of 25x squared, he's going to have 28.45 x squared. So Colin's revised savings plan would be y equals 28.45 x squared saved at the end of each month. So Brian, we already knew made it, so Brian was fine with his, Brian is fine with y equals 2 to the x. So we looked at Alan's. How do we change that? He needed to save k per month, and we managed to work out that k was 258. So if he saves $258 per month, and adds that to the $1,000 he's got originally, he will have his $4,096 after 12 months. Colin originally saved with a savings that allowed him to have 25x squared at the end of the x months, and we said if he needs to have 4,096 at the end of 12 months, we need to be finding out this, solving this equation here, where j is that instead of 25. We worked through that and found that j was 28.444, and I've rounded that up to make sure that he's going to have enough. If I'd rounded it down to 25.44, he'd come a little bit short of that 4,096. And Brian, we said, was fine. So let's have a look at how this question 3 would have been marked. So in question 3, there's lots of opportunities for little U marks here. Writing an equation for Alan's savings, that alone would get you a U mark. Or drawing Alan's savings plan on a graph, that would get you a U mark. Forming the equation for Brian's, so realizing or working out that y equals 2 to the x, and this doubling each time, so told me that it was an exponential with a base of 2. Or drawing the graph of Brian's. Whoops, there's Brian there. Sorry, Brian's that one there. Okay, drawing the graph of Brian's would have got me an achieved. Any of those 4 things would have got me an achieved. We were told Collins, so we're not going to get much for that. Writing these 2 equations would give me the merit tick, or drawing 2 of the 3 graphs. Okay, and really you needed to form the table for Collins to form the graphs. I suppose I could have formed 3 tables, one for Brian, if I'd filled in some more figures, one for Colin, and one for Alan, and compared those 3. And I expect that that should have given you a merit mark as well. Now to get the excellence, drawing all the graphs and looking at the totals after 12 months, making your conclusion would have given that. Alternatively, forming the equations for Alan and Brian and Colin and evaluating them at 12 months to see who was there first. Okay, there was the possibility that someone might have got there before 12 months, so you know, just evaluating them at 12 months could have been a bit of a risk. But doing what I've done there, all the equations written out nicely, the 3 graphs given, that's going to give us a T towards an excellence. In the second part, I know it said to investigate. Okay, we could have done an investigation and just tried different values for the amount that Alan saves each month, and we could have tried different values for the equation for Colin, and that should have given us a start anyway. Finding this value, k equals 258, the amount that Alan needs to save per month, that there would have given us a U. Solving for Collins, okay, and finding this J would have given us an R, because it's a little bit more tricky. To get the T, we need to have both of these worked out in some way, the 258 for Alan and the 28.45 for Colin, and really important that we rounded it up to make sure that he gets to that total, and that would have given us a T. So I'm going to get myself a T for that. And now let's have a look at the overall grade for that question. So for this question, as for the other 2, leaving it blank or having nothing relevant, you're going to get an N0. Having partial evidence in one question, so getting a good start on one of them that's relevant, could give you an N1. Having one U across the whole question, an N2. 2 U's in A3 and 3 U's in A4. Now there were only 2 U opportunities in this question, so it would be a little bit hard to get 3, but they, you know, that's the mark schedule. 1 R would give you an M5, 2 R's an M6, 1 T an E7, and 2 T's an E8. So altogether I've got 2 T's. I'm going to give myself an E8. And now we can have a look at how the entire paper would be marked, how those marks are pulled together. So for my paper, we've got an E7 in question 1, an E8 in question 2, and an E8 in question 3. Now we add these 3 numbers together, 7 and 8 gives me a total of 23. And to find the total grade, we need to look at what they call the cut scores. So for this paper, if your total here was between 0 and 8 inclusive, you'd have a not achieved for the paper. You simply haven't shown enough in the paper to get those grades. Between 9 and 14 would give you an achieved grade, 15 to 19 a merit grade, and 20 to 24 an excellence. So my total of 23 is going to give me an excellence. Now what's worth noting here is you could do really well in one question, say do the first question really well, get that E7, and you could still end up with not achieved. But by trying each of the questions, getting an A3 in each of the 3 questions would give me that 9. So it's really important to try every part of every question. Every opportunity you turn down to get a little U, which will count towards those A's, is keeping you well away from getting those 9, the minimum to get achieved.